So let's look at something that has sort of a tricky solution. This is one of those things that I really want to get you guys thinking about all the things that can possibly happen and really start to connect all of these ideas together. Because remember, trigonometry is really about relationships and remembering when you can apply things and when you can't. So I want you to see lots of different situations in which maybe something isn't going to act like you expect it to, but if you remember your trigonometry, if you are doing well with trigonometry, then you are going to be okay. So let's look at example 3. This is going to be cotangent of x times cosine squared of x is equal to 2 cotangent of x. Now, the immediate thing that I think of here is, do I want to use some sort of identity? Now, cosine and cotangent don't really have a relationship, a good relationship, without converting things to sines and cosines. So in other words, I don't really have a Pythagorean identity that's going to connect these two. So instead, I'm going to try to factor it first. And again, this is one of those things that, just like with when we were doing our verifying identities, you might have to think about a few different ways to do this. You might try to do this by factoring first, and you find out that you can't do it. Then you have to move to identities. Or you might try identities first and find out that those don't work. So dead ends are completely okay, and they're kind of part of the process. Something might look like it is meant to be factored. This, to me, doesn't really look like it's meant to be factored. But then, when I actually try factoring, it's going to work out. So again, if you struggle a little bit, if you have to work a little bit harder, that's perfectly fine and perfectly natural for these type of questions. Okay, so my solution. So again, I'm going to start out with my example. What I'm going to do is I'm going to subtract 2 cotangent of x from both sides, giving me cotangent of x times cosine squared of x minus 2 cotangent of x is equal to 0. And then what I'm going to do is I notice that I have a greatest common factor here when it comes to cotangent. So what I'm going to do is I'm going to factor out a cotangent from both of my pieces of my left-hand side. And what that's going to give me is cotangent of x times cosine squared of x minus 2 is equal to 0. And this has put me in a perfect place, because now I have one factor and I have two factors, and I can use that zero product property. So if you remember that if I have a times b is equal to 0, then a is equal to 0 or b is equal to 0 by our rules of algebra. So in other words, I can set both of these equal to 0 and solve. So in other words, this gives me cotangent of x is equal to 0, and cosine squared of x minus 2 is equal to 0. Or that cotangent of x is equal to 0 because it's just by itself, and then we can do our basic solution here. Now notice that cosine of x is equal to plus and minus the square root of 2 because I had to take my square root here. But the problem is the square root of 2 is 1.41, and this is outside the range of my cosine. So in this case, I'm not going to have any actual values that are going to be coming from this cosine because they're both going to fall outside the range, meaning that I'm not going to be able to find a solution that's going to be equal to 0. So in this case, we only have the basic solution at cotangent x is equal to 0 of x is equal to pi over 2. And since my cotangent and my tangent both have a period, which is from 0 to pi, then my general solution is going to be x is equal to pi over 2 plus n times pi. Okay, so this is what I meant by something that's a little bit more complicated. So not only is it a little more complicated because we have a little bit more math to do, and we have to bring in some factoring, which most people hate. I'm going to completely acknowledge that most people hate factoring, even though it's super useful. So the fact that we have to bring in factoring here, and then some of our solutions don't work because they fall outside the range of our cosine function, those things tend to complicate these questions. All right? So this is going to be one of the more difficult ones for solving a single angle because we have both factoring and something that doesn't work. So these are things to keep on the lookout for when you are solving these types of equations.